Our goals for this lesson are to write exponential growth or decay models using f of x equals a times b to the x and use it to answer questions. For exponential growth, your b value will be 1 plus the percent rate as a decimal. Decay will be 1 minus the percent rate as a decimal. Another goal is to write a logistic growth function given the y-intercept, both horizontal asymptotes, and another point. Our first example will be dealing with population. So given the population of Glenbrook in the year 1910 was 4,200, assume the population increased at a rate of 2.25% per year. Write an exponential model for the population of Glenbrook. Define your variables. So our variables here, when we're looking, we want to use the form y equals a times b to the x. So in this case, y is going to be our population. Our b will be our growth rate. And x will be time in years since 1910. It's a lot easier to talk about years since 1910 because that'll give us, year 0 will be the start at 1910. So here, a is our initial value. Our initial value is 4,200. Okay, b is our growth rate, so we're going to do 1 plus. Our percent increase was 2.25%, so as a decimal, 0.0225. And then we can just put this into our equation as y equals our initial value, 4,200, times our percent rate as a decimal, 1.0225 to the x power. Okay, so this is an equation we'll use to answer the next couple of questions. The first question says determine the population in 1930 and 1900. So 1930 is going to correspond to 20 years after 1910, so t is 20. For 1900, that's 10 years before they started recording, so that'll be a negative 10. You're going 10 before the start. So all you have to do for these is plug in your values. So here, I'm going to have y equals 4,200 times 1.0225, and I want to know what happens after 20 years. So you can plug this into your calculator and round it to the nearest whole person, and you'll get 6,554 people. So in 1930, there were 6,554 people in Glenbrook. Now, if I wanted to go back and see what happened in 1900, I can use the same equation, except this time I want to know what happened 10 years before my start. So I plug in negative 10, and then you'll find out that you had 33,362 people, which makes sense because it's less than what you started with, and the population was growing. Now my last question is determine when the population is or was double the amount. So here I'm going to take my original, which was 4,200, and I'm going to double it. I want to know when that's my population. So I want to know when that is y. So y equals a times b to the x. We're using our original formula. So 2 times 4,200 is 8,400. Our initial value is 4,200. Our rate of growth. And now I want to see when this is true. So I can divide by 4,200 and I'll get 2 equals 1.0225 raised to the x. So now, until we learn how to use logarithms, we're just going to find the intersection on our calculator. So here we can go to y equals, we can plug in 2 for the left side, and we can plug in 1.0225 raised to the x power for the other part. And we want to figure out where these cross. So we go to our graph, and we see they're not quite crossing. So the best way to deal with this is to zoom out. We'll zoom out. Okay. And you're going to calculate your intersection. So you hit second, calculate, go to intersection, which is number 5, and let your calculator do the work for you. And you'll see that it'll intersect when x is 31.1518. So my x equals 31.1518. Okay, so after 31 years, the population doubles. So we started in 1910 plus 31 years. So we'll be in 1941. So in 1941, the population will have doubled. Another use for our exponential functions is going to be half-life. Okay, so we want to express the remaining amount of substance as an exponential function of time to find your variables. Okay, so we're going to say let x equal time in days. And we're going to let f of x equal our mass in grams. So here we have f of x equals a times b to the x. So f of x is our mass in grams. A is our initial amount. Here we had 10 grams initially. Our rate is half-life. So half-life means it's decaying, and it's decaying at 50%, so 1/2 of our rate. So you have half of the original, it's called half-life. And then your time, it's decaying every 14 days. Okay? So it decays every 14 days. So you have to divide by 14. So your final equation is going to be f of x equals 10 times 1/2 raised to the x over 14. There's your equation for half-life. Now we're going to use this equation to determine when there will be less than 1 gram remaining. So I have my equation. And I want to determine when there's less than 1 gram remaining. So my final amount, we want to be less than 1. So this is say greater than 1. We want to make sure that 1 is the most it can be. We can divide by 10 to make it a little bit easier. And again, until we learn logarithms, we're going to use our calculator to determine the intersection between 0.1 and this over here. So you can plug that into your calculator and check to make sure that you can get your answer of x equals 46.507. So there will be less than 1 gram remaining after 46.507 days. Okay. And the last thing I want to talk about today is determining a logistic equation given asymptotes, a y-intercept, and another point on the line. So your logistic equation is of the form y equals c over 1 plus ae to the negative bx. We already know that c is 500, so we can go ahead and plug that in. And now we want to find a. So to find a, we're going to use our y-intercept, or our initial value. The y-intercept is we're going to use the point right here, which is 0, 5. So we have 5 equals 500 all over 1 plus ae to the negative b times 0. what happens is this entire e to the negative b times 0 becomes 1. So this goes to 1. And what we are left with is 5 equals 500 all over 1 plus a. Multiply over by the 1 plus a. Divide by 5. And subtract your 1. So a is 99. So far our equation looks like y equals 500 all over 1 plus 99 e to the negative bx. The last thing we have to find is b. So to find b, what you have to do is use this extra point. So we plug it in, 135 equals 500 all over 1 plus 99 e to the negative b times our x value is 24. Now at this point you can simplify or you can plug it straight into the calculator. So to simplify a little bit, just to make it easier to plug in, I'm going to cross multiply. So I have 1 plus 99 e to the negative 24b times 135 equals 500. Divide. And at this point I would stick it in the calculator and figure out where this intersects with this. So you can put this into y1, this in y2, and figure out where it intersects. Eventually we're going to use logarithms to solve this. You're going to find that b ends up being 0.15. So make sure you use your calculator. Your final equation is y equals 500 all over 1 plus 99 e to the negative 0.15x. And this can be used to predict here. Okay, and this 500 came right from here. Your top asymptote is where that 500 came from. So make sure you can solve these problems, and that'll be it for today's lesson.